Hi, I'm David Vye. I'm the Director of Technical Marketing at AWR Group with National Instruments, and I'm joined here at IMS 2018 with Eric Leclerc, who is the Field Applications Manager with UMS. How's the show been for you, Eric?
The show was nice and very busy yesterday.
Good.
Yeah,
so we have a partnership with UMS. Maybe you could tell people who are watching this video a little bit about UMS and what your role is at the company.
So definitely. So UMS is a European provider for gallium arsenide and gallium nitride solution. The foundry activity is about 20% of the overall UMS business. And this foundry activity was strongly increasing last year by more than 50%. So we have customer-based, worldwide customer-based increasing. And for sure, we have more and more foundry customers who need the microwave office PDK.
Well, very happy to hear that. So what are some of the processes that are driving your growth, and what are the trends in popularity?
We have in our portfolio 12 processes, from gallium arsenide pHEMT, low noise pHEMT, gallium arsenide power pHEMT. We also have Schottky diode, MESFET process, HBT process, and the last one is a GaN. We have a quarter micrometer GaN process, which is used for application up to 20 gigs.
Okay, well, I was going to ask, what type of applications are driving the processes?
Mainly, I would say first defense for S, L, C, X band radar, phased array radar. Also for electronic warfare. I should also mention space. We have more and more activity around the satellite communication, so KA, KU band. And last interesting activities also around 5G millimeter wave, where we have requests on 28 gigs and also for 39 gigs application.
Very interesting, yeah. So
both for GaN and GaAs.
You mentioned the space qualification. I imagine there's quite a bit that goes into qualifying GaAs devices for space.
I would say GaAs and GaN, because we also completed the GaN qualification end of last year. So it's the aim of UMS to serve all the customers, including space customers, with space evaluation of all the processes we have.
Does that process make you one of the few foundry providers for space qualified
Definitely.
devices?
I think, for example, in Europe, we are the only one we have GaN space evaluated process, and we serve customers around the world. So not only in Europe, but also in Asia, in Japan, in India. In US, we have space customers everywhere, which are using the GaAs and GaN process of UMS in foundry mode also, through the support of the microwave office PDK.
Well, I appreciate that. And I imagine with your role as a field application manager, that design support is a big part of what you need to do, and supporting design kits and helping your customers be successful in designing.
Definitely, this is one of the strong points of UMS, is the quality of the PDKs. You know, to manage efficient foundry business, the key factor is to deliver good models, good electrical models, and good PDK. So this is why for UMS it's important to work together with you in order to constantly improve the quality of the PDKs, and, for example, to find some tricks to help designers to generate good layouts in a quick way. For example, recently with your support team, we developed a trick to stack the line with different metals in order to help the designers to generate banded line automatically by stacking the metals, taking into account the design rules automatically.
Automatically, yeah. That's very interesting. We had a conversation before we started filming. You were telling me about, and you presented this at our design forum, thermal modeling and incorporation of those effects. Can you elaborate maybe a little bit?
Exactly, you're right, definitely. The point is that for the GaN mainly, we had to develop a specific model which takes into account the non-stationary effects. And our modeling team has worked a lot about the tricks and the solutions, advanced solutions to take into account these non-stationary effects like thermal effects.
Okay.
And we have been working with your team also in order to implement this thermal effect in the model. So it means that during the simulation, the designers can extract the junction temperature directly. Okay. And some other effects also are taken into account, which is a key factor to get good simulations, not only in CW, but also in pulse mode or with a complex simulation scheme for example, for some telecom application where it's important to simulate the linearity of the device.
Okay, and well, we're talking about telecommunications. I heard you mention 5G. You can talk a little bit about the processes that you're seeing to support 5G. I imagine millimeter wave. I thought I heard you say. Can you
definitely 5G is one of the driver at the moment. For that we have GaAs process and GaN process. So I will start with GaAs process. We have, for example, the PPH15X process, which is really optimized for power generation up to 45 gigs. So can be used for power in the different millimeter wave bands. This process is quite unique because it's a state-of-the-art process which is providing high power added efficiency and high linearity.
Okay.
This process is fully compatible with plastic packaging, and all these options are included in the PDK. Another process we developed for the high frequency band is PH10. PH10 is a process dedicated mainly to E-band, and through this process the designers can design LNAs, mixers or drivers up to very high frequencies too. This is for GaAs, and now for GaN, where we need also power. We are at the moment developing a new process which is GH15. This process is going to be qualified and open in foundry mode beginning of next year, and through this process designer would be able to design a power amplifier up to 40 gigs or 45
40 gigs. Yeah. And like what power levels would people?
With high power, so in the range of 4 watts per millimeter. Yeah.
Okay, so like fixed wireless applications, or what do you envision the application?
For example, yeah.
Yeah, okay. And I would imagine a lot of the work that you've done, you mentioned aerospace defense designs to your founder. I'd imagine a lot of that technology is transportable to tackling 5G.
So for telecom application, we developed some Doherty solutions, which are very helpful to increase the power added efficiency in a wide range of input power.
Okay.
And these techniques are mainly today interesting also space space and defense guys. Yes, you're right.
Yeah. It is very interesting to watch the satellite market grow itself. Moving towards nano satellites, and it just seems like there's a lot of activity in that space.
And exactly. And another point, you're right on mentioning the interaction between them. It's that that for 5G, more and more people are considering the antennas and beamforming solutions, which are traditionally more used in the defense market. So we can benefit from them. From that.
Great.
Yeah.
Just maybe one more thing, as you mentioned. So a portion of your business is foundry, but also you sell power devices, and maybe you can talk a little bit about
Definitely, David, the good point to mention that, because it's not only for foundry that we need PDK.
Yeah.
We have a part of the activity in UMS which is related to product, GaN product. We deliver, for example, transistor in die form or in package. And for this kind of high power device, the designers, customers, they need to have a non-linear model. So this is why for that kind of product, it's important for us to deliver to the customers some mini design kit. It's not like a big design kit we have for foundry, but it's a small design kit which includes a model of the transistor inside the package when the transistor is packaged. And this is the way the designers are able to tune the transistor
Yep.
according to the frequency bands, and in order to extract the power they need and the power added efficiency they need,
Okay.
or the linearity they need eventually.
So discrete transistors either in chip form or package form, and you have design kits and models to help support that. And that could be leveraged with, I don't know if you've seen capabilities in our version 14, but we're introducing impedance matching network synthesis, which I think will dovetail very well to help make designers successful in that work as well.
Exactly, David.
Yeah.
It's a point where we work a lot with your development team in order to implement, as soon as the market is demanding that, on the different power bars offered by UMS, packaged or not, to offer the PDK for nonlinear simulation.
Okay. Well, we're looking forward to continuing the partnership, and we appreciate the support we've gotten from you in the past and serving our mutual customers. And I thank you for your time at IMS.
Thank you, David. Thank you for that.
Thank you very much.
Thank you.